Hi everybody, this video is going to talk about function notation and evaluating functions. So function notation is just a different way to write an equation. Typically we're used to seeing equations written as y equals something. In this example it's y equals 2x minus 8. If I wanted to write this equation in function notation form, all I'm doing is I'm replacing the y with f of x. And we're saying f of x is equal to 2x minus 8. So the way that I'm saying this is I'm saying f of x. Okay, and this is, you can kind of think of this as a different naming system. We use function notation a lot when we have multiple functions we're working with, and we can name one of them, let's say f of x, and the second one could be g of x, and that helps us differentiate between which of the functions we want to work with. It's also a helpful notation for when you are evaluating functions, which is what we're going to take a look at in this video for the most part. So evaluating functions. To evaluate a function, it means that we're going to substitute, which means plug in, a specific value for the x in a function. So in this case, our function is f of x equals x plus 7. So mentally, you can kind of think of this as just y equals x plus 7. And this isn't a multiple choice question. This is a multiple part question. We want to find f of 5, f of negative 1, and f of negative 3. What that means, we want to find what is the y value of the function when x is equal to 5. Okay, that's what I want you to mentally think. When you see f of 5, what you're trying to figure out is, what is the y value of this function, f of x, when we have an x value of 5? Now, it's pretty easy to figure this out. If I want to know what y is, when x is equal to 5, I just plug in 5 for the x that's in my function. So we have f of 5 equal to, okay, up here it's x plus 7. We're substituting in 5 for x, so we have 5 plus 7, which gives us 12. So that means when we have an x value of 5 for this function, the corresponding y value is 12. And we get that value by just substituting in 5 for x in the function that was given to us. Okay, similarly, if I want to find f of negative 1, I want to find the y value that pairs up with an x value of negative 1 for this function. So I'm going to plug in negative 1. Okay, negative 1 plus 7 gives me 6. So that means for this function f of x, when x is negative 1, y is 6. Okay, when x is negative 3, oh, not plus 6, plus 7. When x is negative 3, the y value is 4. So we're looking for a specific y value that pairs up with a specific x value. Okay? When x is this, what's y? That's what I want you to think about when you see function notation and when you're evaluating functions. So let's look at a couple. This was a pretty basic pattern. We were just adding 7 each time. Okay, let's make it a little more complicated. For this example, we have f of x equals x squared minus x. So if I want to find 4, then I need to plug in negative 4 for x. Now, you have to be careful when you write this. I want you to write it as parentheses negative 4 squared minus parentheses negative 4. Now remember that squaring a number means we're multiplying it by itself. So negative 4 times negative 4 gives us a positive 16. So this is really 16. And if I'm subtracting a negative 4, that's the same as adding 4. So we get 20. So we found that for this function, when x is negative 4, y is 20. And I can do that for each of these. We plug in negative 1. Negative 1 squared is positive 1. And we're subtracting a negative, so that's really the same as adding. So we get 1 plus 1 is 2. So when x is negative 1, y is 2. When we plug in 7, okay, 7 squared is 49, and then I'm subtracting 7 from that. so we get 42. So you get the idea. We're plugging in the given x value to find what is the y value at that particular x value. Now let's do one with a fraction here, because I know everybody loves fractions. Okay, it's the same deal, right? I've got negative 1/2 times x plus 9. Now notice, instead of f of x this time, we have g of x. Okay, that doesn't really make a difference though, okay? That letter can be really anything. It could be f of x, g of x, h of x, z of x. It can be whatever letter. It doesn't really make a difference. Okay, it's just a different letter, really just to differentiate between the functions. So don't get too caught up on that. Okay, if I want to find g of negative 8, that just means I'm plugging in negative 8 to g of x. Okay, so negative 1/2 parentheses negative 8, so I plugged it in, plus 9. Negative 1/2 times negative 8 is positive 4, plus 9 gives us 13. Okay, if I want to find g of negative 2, I plug in negative 2. So negative 1/2 times negative 2 is positive 1, plus 9 gives us 10. I plug in 0. Okay, anything times 0 is 0, so we get 0 plus 9, which is 9. So that's all evaluating is. It's substituting in a value for x, and then using your order of operations to simplify. So we're finding, again, I'm going to repeat myself a lot here, we're finding the y value at a particular x value for this given function. Now let's look at it a slightly different. Okay, let's look at it when the function isn't actually given to us as an equation, it's given to us. So this graph that you see represents the function f of x, and we need to find f of negative 4, 0, 2, and 5, but I don't have a function or an equation I can plug it back into. So here's the thought process. F of negative 4 is really asking us to find the y value for this function when x is negative 4. Well, let's look at our graph. Here's the point on my graph that has an x value of negative 4. So if we write this ordered pair, this is the ordered pair negative 4, 2. Well, that's telling me that for this function, when I have an x value of negative 4, I have a y value of 2. Okay, or for f of 0. Okay, here's my point on the graph with an x value of 0. This is telling me for this function, when x is 0, y is 0. When x is 2, y is negative 2. And when x is 5, y is negative 1. So we can do the same thing if we understand what it's asking us to find. Using the graph is actually easier because we don't have to make a calculation. We can just find the ordered pair on the graph and look at the y value that matches up with that given x value. Okay, so that's it for evaluating functions. Remember, when you're evaluating a function, you are substituting in a given x value to find the y value that corresponds with it for a particular function. I know that's a mouthful, but take the time, practice, rewatch, ask questions. All right, that is it for this video. Hope you all have a great day.